if I had a table, but yet I had a formula that produced that table, I should really be looking at the formula and not the table. If all I have is the table, then that's all I have, and I also have to be aware that only having a table of values representing my function is very restrictive because I'll have students like for part A it says, what's the domain of f of x? And you can see that the first table is our f of x function. They would say the interval from -3 to 3, and that's wrong. -3 to 3, because that's what my x values run from. They go from -3 to 3. And you're partially right, but then I have to pose the question to you, well, okay, with that table, tell me what f of -2.5 is. And it's like, I don't know what it is, or I would have to take a guess. I'd say, well, that'd be like 3.5. Well, how do you know that? Well, you went halfway between your x's, so I went halfway between my y's. Well, does the table say that's what's happening? Does that table really tell you? I mean, how do I know, like, between these dots? And because when I look at that function, it looks like it's doing more along the lines of this. How do I know it's not doing all sorts of cockamamie things between, like this? So how do I know what's happening at -2.5 at all? The fact of the matter is I don't. And because of that, there are undefined values, for this thing. So when I state the domain and I say -3 to 3, I'm saying, well, all x values between -3 and 3. I mean, it's like -2.5, -2.9, -2.99. I have a y value that I can evaluate for it. I don't. I don't have it. That's not in the table. So this has to go too. Because all I have is a table and no formula, no graph, anything else that lets me get a better idea of what the function may look like. All I have is a table. All I could do is list them and use my set notation. So that's my domain of f. So again, if all you have is a table, when you list the domain, it has to be individual values. You cannot give an interval, because an interval means that all values between those are also included. Same thing with the range. The range goes from -2 to 4, but it's only those numbers, -2, -1, 0, 1, 2, 3, and 4. And I look at the domain and range of G, same kind of thing. Now, at this point, one of the questions that sometimes is asked of students, like at this point, they'll say, well, then, if I look at this, then I mean the domain of f is the same as the range of G, and the domain of G is the same thing as the range of f. Are these things, in fact, inverses? Well, you just don't look at the domains and ranges, because it really the matching up of certain things is going to matter. Okay? So you have to be very careful about that, because if they're not matching up in the same kind or similar manners, then no, they're not going to be inverses. I mean, so we're going to look more into that, because when I look at like for instance, give the table of values for f -1 and give the table of values for g of -1. Pretty straightforward, because again, when I do the inverse of a function, I am switching domains with ranges. So I'm going to take the values for f of x and replace them. I'm putting them in order, typically for the x's. And I'm just matching up the y value, the original x values that went with those y values. So at -2 for the y value, I had an x value of 3. Now that's my new y value. At -1 for my y, I had a 2, so forth and so on. So I'm just switching my x's and y's and making sure to put my x's all in order, and the y's have to still be associated with the original x, or I should say that the new y is associated with the old y, which is what x is. And g -1, same kind of thing. Switching my x's and y's, making sure that I also list my new x's in the right order. That's what I would get. And I'm going to look at these in a moment. I'm going to leave these here because I'm going to do some comparisons that kind of let me know that f of x and g of x are in fact not inverses of each other. But now I have enough information to say, okay, like what's the domain of f -1? And I can see it runs from -2 to 4, again, listing the numbers. Very similar to what I did in the first 4 instances of when I was looking at f of x and g of x. If I do fog f of g of x, if these were in fact inverses of each other, then I would expect to get plugging in -3 would get me back -3 when it was done. That would happen for every number I have here. Let's have a look and see how we would go about doing this. If I'm doing f of g of x, and first I'm going to start with the innermost functions domain. So that's why you see here, if I can get the right color here, give me a second. I'm starting with g of x's domain, and g of x's domain is this group right here. So that's the first thing. That's how I start off my table. Now, with that being said, we'll get rid of these. If I get the eraser to show up, that's always a good plus. And bam, bam. So basically, if I'm going to do, like, for x being -2, I'm going to start with -2, plug it into g of x. That becomes 0. That 0 becomes the input I'm going to use for f of x. So I plug 0 into the f of x table. I get 1. Therefore, that's what the y value is going to be on my table. For -1, again, I'm going to start at -1 in the g of x table. Let that be the x value, which gives me a y value of -3. That -3 becomes now the x value for f of x, and that produces a 4. So the y value I'm going to have down there is now going to be a 4. For 0, 0 is going to become 1. That 1 is going to become back into a 0, and I plug it into the other function, so it's going to be 0. The 1 goes to -2 in g of x. That -2 is then plugged into f of x, and it's going to produce a 3. And so forth and so on. You get the idea of how later we're moving about this, hopefully. So that's my table of values. Now, if they had in fact been inverses, my x and y column should always have the same number. So it'd be -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 2, 3, 3, 4, 4. That would be an indication that I would have, of two inverses together. Because again, if I compose them, I end up with the x value again. Same thing with g of f of x. And here I'm just going to kind of show it a little bit more shortly. Again, I'm starting with the innermost domain. I'm starting with f of x's domain. That's why I have the x's go from -3 down to 3. And then again, I'm going to follow, start with -3, I'm going to go to 4, then 4 is going to go to 2, that sort of thing. And I'm kind of showing it right here with different colors. So -3 goes to 4, 4 goes to +2, -2 goes to 3, 3 goes to -1, so forth and so on. And I have a nice little rainbow up there. You get the idea. That's how I fill in the table. Again, G and F are not inverse. I mean, when I look at the domains and ranges when I write out the list, oh yeah, the list, because I usually write them in numeric order, yeah, they look like, they're, the domain of one's a range of the other, but it doesn't quite work that way because how they match up is also important with that. Getting back to these, now if I do f of f -1, yeah, if I go through that entire process I just did, so I'm looking at the ones on the left here. If I start with this one's domain, if I start with this one's domain, that means I'm going to start with these x values here. And so -2 becomes 3, 3 becomes -2, and -1 becomes 2, 2 becomes -1. If I keep working with that, I keep on seeing this. But again, that's what I would expect to happen if I take a function that's inverse and compose them together. Whenever I start with an x value, I should get back that x value after I do the two functions operations together. Same thing for L's. Now I just took a shortcut. I said, well, I started with g of x's domain. Make sure that got transferred down here. But as far as me doing the composition, then I should end up with the exact same value as I had for x for my y value. And that's how I got the answers that you see here.